Okay, so we're going to start talking about the seasons. And so there are two ways that the Earth moves around in space. One is that we move around on our little axis and we're tilted 23.5 degrees from being perpendicular, our axis being perpendicular to the sun. And the other way is that we revolve around the Earth. So you can think about this as you're standing in one place and you turn around and around and around until you get dizzy and you fall down. For revolution, you can think about it. We put coach here in the middle, everybody joins hands, and we play ring a ring a ring around the posy, and then we all fall down and laugh at coach. So we are tilted 23.5 degrees. So if we were perpendicular from the sun, so over here, this distance here would be 23.5 degrees. So here's our definitions of rotation and revolution. We all know this because we care, because we want to know how old we are when it becomes our birthday. Once you get past 35, though, you usually don't talk about that. For me, I have to subtract the years in my head because you kind of just don't want to talk about it anymore. Okay, so there are a lot of misconceptions about why we have seasons. The first one is, this is how you've always seen it represented, that the Earth's orbit is this elongated ellipse. And it's actually not like this. So think if you had a hula hoop and you angled it a certain way, you would see this. But if you turn the hula hoop to where it's right in front of you, it would actually be a circle. So the one misconception we have is that the Earth's orbit is elongated, with it being elongated at the two ends. A group of people did a survey or walked around Harvard and asked normal people things and some of the collegiates about their misconceptions about the seasons. And the first one is this, and it was asked which one correctly represents the shape of the Earth's orbit. A lot of people picked C and D. C being this idea that the Earth's orbit is an ellipse, meaning that it's stretched at the end. This is how you see it in your textbooks. A lot of people put this, but this is where the sun is not in the center. So this dude comes over here and it's very, 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 very hot, crispy critters. And then when it's over here, very, very cold, we got some ice pops going on. So the more correct answers belongs in A and B. Some people chose B, thinking that we're closer to the sun here, so therefore it's summer, and then we're farther away from the sun here, therefore it's winter. The correct answer is that the Earth's orbit is almost a perfect circle. It's not quite a perfect circle, but pretty darn close to it. Again, that 23.5 degrees that we're tilted. So this thing about less direct sunlight and most direct sunlight is very, very important. When the axis for us in the northern hemisphere is pointed towards the sun, we get direct light. When it's pointed away, we get indirect light. A day and night cycle, we talked about this with our last, was it a quiz? Where here is where we are in day, here is where we're in night, and it asks where the sun went. Well, the sun never moves. We rotate. So if we're in the sun here, our neighbors on the other side are in the dark. You guys have this as definitions: spring equinox, autumnal equinox. That's when there's close to perfect equal days and nights. Not perfect, but close to it. Solstice, the summer one, is where the sun reaches its spot highest in the sky. Things rise in the east, go high in the southern sky, and set in the west. The winter solstice, which is coming right around the corner, is when the sun is lowest in the sky, and this will be our coldest day. As soon as that happens, then the sun starts marching back up to the equinox, in which the days start getting longer. Notice here that the Tropic of Cancer and Tropic of Capricorn are 23.5 degrees away from the equator, not a coinky dink. This is because of that tilt. And if you remember from your geography or geology or history, that around this band is where all the world's tropical rainforests fall because it's warm all the time and there's a lot of rain that occurs. So if we're standing on the North Pole, this becomes quite interesting. On the summer solstice, there's no dark, and the sun is in the same place. So a lot of times if you look at Alaska Troopers or watch something about Alaska, they have very, very dark curtains over the windows, or they cover them completely. That's to block out the sunlight. Sunlight can affect your circadian rhythm, which is your body's ability to go to sleep and wake up. And so here it is on the equinox. It's not high in the sky, so it's not hot. It runs around the horizon. So if you can imagine, here's where the sun gets up, and then it just goes around like this until you go to bed. It's always up. And then in December, they have no sun at all, so it's completely dark. A lot of seasonal depression happens in Alaska and the North Pole here around here because of all the darkness. Sun makes us happy, I guess. Here's an example of the midnight sun. This is the time of day that goes by at the North Pole. There's a misconception about, one, us being closer, and two, about the sunlight that's coming next to us. So here has to do with distance. They ask this question also. And a lot of people don't understand scale. And if you remember, we did that. And a lot of us had the misconception of the scale of the sun and the moon and the earth. And C is the correct answer. So this distance between us and the sun, no matter which side of the sun we're on, really isn't significant. It doesn't affect our seasons. Direct and indirect light does, though. When the sun is high in the sky, it's like someone shining a flashlight directly in your eyes. When the sun is low in the sky, well, they're not shining it directly in your eyes. It comes at an angle. Just an example of those angles and the directness of the sunlight. Again, same thing. In this picture, the northern axis, where we're at, is pointed away from the sun. So we are getting indirect light, versus the southern is pointed towards the sun and they're getting direct light. Same here. We're pointed towards, we're getting direct light, so it'd be summer actually, and they're getting indirect light, which would be their winter. So if we look at how the sun rises and sets, remember it rises in the east, goes high in the southern sky, and sets in the west. When it's highest in the sky, and you go outside and look at the same place at the same time, at noon, it's going to be at its highest point. At the equinoxes, it's going to be almost exactly in between its highest point and its lowest point. And then in December, it's its lowest point in the sky. So here it's going to spend a long time up in the sky, and here it's going to spend less time in the sky. So we have summer, we have lots of sunlight, lots of the day is sunlight, and here we have less of the day that is sunlight. Oh, aren't sundials cool? Okay, so AM and PM. You can go home and say, hey, Mom, did you know it's AM because the sun is not crossed the meridian in the sky, and it's PM because it's after the meridian in the sky? You just learned something. Go play Jeopardy! Okay, here are some neat pictures of the solstices. Here would be the summer solstice, high in the sky. Look at all this time it's there. And here it's very low in the sky. So this location, I don't know where it's at, would have probably more of an extreme winter and summer than we would. Here are your graphs. Let's tie it back to your homework that you did while I was gone, which should have been easy for you. At the equator, the days and lengths are equal. And as we go from here to here, guess what days those are? Yep, you bet it. It's March and September. Those are the equinoxes. So we have equal day lengths. And then guess what this is? Let's see, June. So we have all day, 24 hours here, and we have none here. So notice that these are mirrors based on their latitude. So longer days, shorter days. Temperature is a little harder to see that relationship, but this is definitely a southern location, and in July it's super duper cold versus us, we're going to be hot in our summer months. So where it peaks on this graph, you can tell whether it's a southern location or a northern location. So there you go, all you wanted to know.